The inexplicable discoveries made by the James Webb Telescope have left astronomers completely baffled. Instead of deepening our knowledge of the universe, Webb's findings reveal a disturbing fact. Our understanding of cosmology is simply not sufficient to explain the nature of the early universe. This has led many to wonder if the tried and tested Big Bang theory has clearly had its day. But why is this once sacrosanct idea now coming under increasing criticism? Stay tuned and join us as we get to the bottom of this fascinating topic. Even those who are not particularly interested in astronomical research know that it all began with the Big Bang. Since its launch, the James Webb Space Telescope, or JWST, has been our window to that beginning. Well, Webb was designed specifically to detect infrared light. As space itself expands, the light from the most distant objects gets stretched out, shifting from visible light into the infrared spectrum. This is a phenomenon we call This makes Webb the perfect tool to hunt for the first, faint, baby galaxies, and in doing so, confirm our understanding of how everything came to be. The expectation was that we would find small, clumpy, primitive galaxies, the seeds of the grand structures we see today. But what Webb has found is causing some to critically question everything we thought we knew. It's a kind of $10 billion time machine, with a giant, golden honeycomb mirror built to capture the faint, ancient light from the very first stars and galaxies. Its mission was to peer back into the cosmic dawn, a period just a few 100 million years after the Big Bang when the universe first lit up. But how can we even see this so many billions of years later? The standard story of our universe. To understand why these new images are so puzzling, we first need to revisit the story we thought we knew. The Big Bang Theory. For decades, this has been the cornerstone of modern cosmology. But what does that actually mean? Well, it states that our universe began approximately 13.8 billion years ago from a singularity, a point of unimaginable density and heat. From this singular moment, space itself began expanding, and it's been expanding ever since. In the first few minutes, the universe was a scorching, dense soup of fundamental particles. As it expanded, it cooled. Over hundreds of millions of years, these slightly denser pockets acted like cosmic scaffolds, their gravity pulling in the surrounding gas. Slowly, these gas clouds would have collapsed under their own weight, igniting the first stars. These stars would then group together to form the first proto-galaxies, which were expected to be small and irregular. Over billions of years, these small galaxies would collide and merge, gradually building up into the larger galaxies we see today. The key words here are slow and gradual. This was the picture JWST was built to confirm. Protons and neutrons formed, and then, after about 380,000 years, it's cooled enough for these to capture electrons, forming the first atoms almost entirely hydrogen and helium. This event, called recombination, released a flash of light that we can still detect today as the cosmic microwave background radiation, which is considered outstanding evidence for the correctness of the Big Bang theory. There were no stars, no galaxies, just vast clouds of neutral gas drifting in the darkness. According to our standard model of cosmology, a framework known as lambda-c, the formation of structure was a slow, bottom-up process. This model assumes the existence of dark energy and cold dark matter, an invisible substance that makes up about 85% of the matter in the universe. After this, the universe plunged into what's known as the cosmic dark ages. The idea is that gravity began to work on tiny fluctuations in the density of this dark matter. Expert opinions, a crisis in cosmology. So, what does this all mean? The bottom line is that the discovery of these universe breakers was not a confusing isolated case, but merely the prelude to a whole series of similarly puzzling Webb findings that literally scream that something is wrong with our standard model of cosmology. But let's be very clear about something. The James Webb Space Telescope has not disproved the Big Bang. The core pillars of the theory of the expansion of the universe and the cosmic microwave background remain unshaken. Finding galaxies in the early universe was, in fact, one of the main goals of the JWST, and a prediction of the Big Bang model. The crisis isn't with the Big Bang itself, but with our models of galaxy formation that are built upon it. The lambda-c model is what's under pressure. It seems the universe was far more efficient at building galaxies than we gave it credit for. The standard cold dark matter model assumes dark matter particles are slow-moving. But what if dark matter isn't so cold? Alternative models could potentially alter the timeline of structure formation. and the JWST data is forcing theorists to reconsider all possibilities. This theory suggests gravity behaves differently on galactic scales, removing the need for dark matter. While Mont has struggled to account for observations on the scale of the entire cosmos, the discovery of these bright, massive early galaxies was a prediction made by some Morn-based models. This doesn't mean Mont is correct, but it highlights how these new observations are breathing life into old debates. To form these massive galaxies so quickly would require them to convert nearly all of their available gas into stars, a rate of efficiency far beyond what we observe in the modern universe. The lambda CDM model will likely be updated, not abandoned. We may discover that the early universe was a more chaotic and diverse place than we imagined. With multiple pathways for galaxy formation, the universe is rarely simple, and JWST is showing us that its childhood was far more complex than the story we used to tell. This makes the situation all the more complicated, as researchers are now discovering something that simply cannot be reconciled with our established models. The data from JWST is not providing a simple answer, but is opening up a universe of new questions. The need to tweak our models could lead to some profound shifts. One major implication is that we may need to revise our understanding of star formation. These early results suggest that in the primordial universe, conditions were ripe for incredibly rapid and efficient star birth. It is, therefore, almost impossible to deny that our understanding of early cosmic development is incomplete. Rewriting cosmic history. Now, we are standing at a pivotal moment in cosmology. No less exciting is the idea of exploring the nature of dark matter than there are more radical ideas. Some researchers have pointed out that these findings align better with alternative theories of gravity, like modified Newtonian dynamics. The most likely outcome is not a complete overthrow of our current paradigm, but a significant enrichment of it. The James Webb Space Telescope was sent to the edge of space and time to answer some of humanity's oldest questions, but instead of providing simple answers, it has returned with a beautiful puzzle. The images of massive galaxies in the infant universe do not break the Big Bang theory. Instead, they are breaking our assumptions and shattering the neat models we had built to explain the aftermath of that cosmic birth. We are witnessing a fundamental shift in our understanding of how cosmic structures came to be. The universe was not slow in its construction. It was fast, efficient, and capable of building grand designs, almost from the moment the lights came on. We are not discarding our book of cosmic history, but we are realizing that the first chapter is far richer and more mysterious than we ever imagined. The greatest discoveries may not be the ones we expect, but the ones that force us to question everything we thought we knew. And hopefully, you've added subscribe to your to-do list. Join our community and never miss another video from us again. We'll see you soon. And that leads to a final, thought-provoking question. If our understanding of the universe's first billion years is being what other cosmic truths are waiting to be challenged? What do you think these incredible discoveries mean? Are we on the verge of a new revolution in cosmology? Let us know your thoughts in the comments below.